All right. So we have requests from the email that I got earlier. This is for Precalculus 8.4 packet. I'm looking at number 10 from 8.4 packet first. And then after that, we'll look at number 2 and 6 from the review, and then number 14 from online homework. All right, so plan on doing 4 problems here. So, yeah. So, the first one is number 10. Okay, so number 10 is number 9. Number 10 is right here. So number 10 says, given the triangle with 2 sides length AB included angle theta, what is the area of the triangle? And what's the maximum area? What is the minimum area? What is domain? What is the independent value? So this problem, it goes back to basically the idea of the triangle formula. So first of all, so area of triangle A is equal to 1/2 AB sine theta. This is because this is just the formula, right? If you have an angle in between and then 1/2 AB sine C, then you get this as your area. So that's the first one. Shouldn't be too much trouble here. The next part is then, what is the maximum area? So you have to examine basically here, let me move it over here a little bit so you don't get out of focus. So you have to look at the nature of this formula, okay? A and B are a constant number, right? So, like, you can't really change A and B because that's just how the size is. But the area of it depends on sine theta. Remember sine theta, if it's an acute, okay, sine is always, so usually sine's between -1 and 1, right? Equal. But because this is a triangle, so you can't really get negative sine values. So this part is gone. So it's just greater than equal to 0. Also, these are extreme cases, right? Sine at 0 is when theta equals 0 degrees, and 1 is when theta equals 90 degrees. Right? These are the extreme cases. 0 degrees would just be like no triangle at all, right? Because this angle is 0. And 90 degrees will be the extreme case, which is like this case, right? 90 degrees. Like this. That's the biggest one. So, the maximum area will then be the 1/2 AB sine when sine is 1. So the maximum would be 1/2 AB times sine theta 90 degrees, which is 1. Okay, it's just that. And then the minimum is obviously 0. But if it's actually at 0, it's not a triangle. So like, it's questionable whether or not it should have a minimum because it's not included. But if you want to include the fact that, okay, this triangle can't open at 0 degrees, then your area can be 0. Okay, so that's just that part. And your independent variable is your theta. Okay, that's your angle that you're controlling. If you're opening bigger, then you have a larger triangle. If you are opening smaller, then you have a small triangle. That's up until 90 degrees though. After 90 degrees, then it switches off again. Okay, it starts getting smaller. but 90 degrees is the highest. Okay, so that's number 10. All right, number 2 and 6 on the review. So we're gonna go to the review part, which is this part. So number 2 and 6 on the review. Number 2, first thing is we are looking at I'm gonna use a different piece of paper to do this because it's gonna take some room. So it's an airplane problem. It says fly on bearing of 55 from city A to B. Distance is 470. All right. And also so I'm going to draw the picture, okay? So bearing is from the north, right? It's from the north. So I'm going to draw the airplane from city A. So A is here. And then, so redraw it because I want to go. It's 55 degrees bearing, so 55. So this is number 2 from review. Okay, 55 degrees. Okay, so go that way for 470 miles, and then you get to B. Okay, after that, you go north 7 degree east. So north 7 degree east. That's 7 degrees this way. And you go 890 miles. Okay. And then finally, you want to find, so that's C. Somewhere here. And you want to find the distance . Wait. Okay, one second. This part, because you're starting from A again. This part, 5 degrees here, that will get 890 here. Okay? It's not B to C, it's A to C. My mistake. Anyway, so you got 55 degrees go to B, and 5 degrees go to C. Okay, that's 890. Okay. So then, after you drew the picture, you're going to look at what is the distance between B and C. So this distance. So this is a simple law of cosine question because you have 2 sides and you have an angle in between and you were looking for the third side, right? And after you get that third side, you can also find the bearing of that. So we're going to do law of cosine. Let's just say call it x. So x squared equals 470 squared plus 890 squared minus 2. 470, 890, cosine 55, which will end up giving you x being 673.2 miles. Okay, that's the first part. And then you will have, so that's the first answer. The second part is the bearing. So bearing is from C to B, right? From C to B. So that's measuring this part. Like, what is this angle? Theta, right here. Okay? This angle, theta. And this is pointing towards the north. Okay? So to do that, what I'm going to do is I'm going to use the fact that I'm going to find this angle first, and then I'm going to subtract So here you go. So this is an alternate interior angle, which is 5 degree here and 5 degree here. And this angle is supplementary to the whole 180, right? So we can find this part as well, and then we can find the whole thing, okay? I mean, there are more than one way to do this, but this is just one of the few things you can do, okay? So this is, because these two are both pointing north and south, these two are both 5 degrees, and you want to find this whole angle first, and then you subtract from 180, subtract 5, and then you get this angle, and then you subtract 180 to get this, okay? So find that angle. So angle C, or measure angle C. To do that, you basically need to use law of sine, which is sine this over that equals sine this over that, okay? The x we just found. So sine C over 470, sine C over 470 is equal to sine 55 over 673.2. Okay. So using that, you should be able to find that measure angle C turns out to be 31.25. 31.25. Okay. 31.25. Now, this angle is not the answer, however. It's just this part. Just this whole thing. Now I need to find this part. Let's call it alpha, okay? So alpha is equal to 31.25 minus 7. Wait, 7? Is it 7 degrees? Wait. Oh, it is 7 degrees, not 5 degrees. My bad. 7 degrees. 7 here, 7 here, not 5, okay? 7, 7. So you have to subtract 7. Okay, subtract 7. Then alpha is actually 24.25. 24.25 degrees. This you subtract from 180, okay? So 180 minus 24.25 equals 155.75. That is your bearing. Because bearing is always from the north and clockwise, right? So that would be it. So the idea, okay, is, once again, you find this length first, and you find this angle using law of sine. I know this is 7 degrees. I don't know why I said it was 5 earlier, but this is 7 degrees, so this part is 7 degrees. This part. Okay, once you get this part of 7 degrees, you find this whole angle, you can find this alpha angle, which is 31.25, subtract 7. And once you get that, you can get this angle by using supplementary. Okay? So that's number 2. Number 6. Similar problem, but it's a surveyor problem. Was contracted to find the area of a plot of land. After finding measurements, he has asked for your help to find the area. Here's the information. Starting at a pond, proceed 325 meters on a bearing of 240. So 240 is this way. So I'm going to start here. Okay. So this is the pond. So 240 means this way 240. Okay. So it's up right here. 240. And this is 325 meters. Okay. And then to the dirt road. Okay. This is a dirt road D. And you do south 50 degree east. So south 50 degree east. 290. Okay. And you reach the So this is 240 and this is 50 to the cattle fence. So let's just call it C, okay? And then northeast along the fence for 300. Northeast is directly northeast, so that way 45 degrees for 300 to get to the stream. And finally you go back to the pond. Okay, so this is your info. So you want to find the area, right? The area of this area. Area of this area. So you want to find this whole area. Okay. So first off, you have to find a way to cut this up because we're trying to use triangles, right? So first off, let's try to find as many angles as possible. Okay. So first, and this one is the same by alternate interior. So I do know this angle. So the area, right? So A1, A2, okay? So A1 and A2. So A1 should equal to 1/2 AB, which is 290, 300 sine 95 degrees. Okay, because 50 and 45, right? So that should give me let's see, 1/2 B sine 95, which is 43,334. Let's just say that, okay, miles, meters squared, okay, that many. Okay. Then, after that, you want to find A2. To find A2, there are several things that you have to worry about, which is this angle right here and this length. So we're going to find this length first. Let's call it X. Okay, so if we call that X, then we can find X squared. This is the law of cosine, right? Equals this square plus this square. So 290 square plus 300 square minus 290, 300 cosine 95. Okay, so X is equal to 435 meters. Okay, so that's that. So now to find this area, there are multiple ways you can approach it. But since I have these two lengths, I want to try to find this angle if possible. Because if I can find this angle, then I can just do 1/2 AB sine alpha, right? So let's see if it's possible, okay? So I know this is 50. This is 50. So, and I also know that this is 60 because 240, right? 180, 240, so 60 degree here. So because of that, 60 here, 60 here, right? This is called alternate interior angles. So if I can find this right here, then I can find that. Okay. So this part is going to be, I can use it based on law of sine here to find this angle. or law of cosine. It's up to you which one you want to use. So if I use law of sine here, which is, I'm going to use the star, okay? So sine star, and then call it anything, okay? Over 300 is equal to, let's use this one then. Sine 95 over 435, okay? So star turns out to be 300 sine 95 over 435, 43.395 degrees, okay? So once you get that, then you can find alpha, which is, so alpha is 180 minus 60 minus 50 minus 43.395, which is 26.60 degrees. So you're going to use this angle, and you're going to do the area 2. So area 2 is 1/2 AB sine alpha, okay? AB sine alpha. So 435, 325, sine 26.6. So I got 31651 meters square. So we add these together. So area total is equal to 4, 74985. Okay, meters square. Okay, that is review number 6 for 8.4. Finally, the last one that a lot of people are waiting for is the number 14 on the homework. Is number 14 the last problem, which is the one sec. Is that the cal problem? Can you guys confirm if this is a cal problem? People are here. Number 14, right? All right. I think it's the cal problem. So I'm just going to do the cal problem, okay? So this is the problem where yeah. Oh, hi Esther. Okay. So let's look at the cal problem real quick. So on my version, so the numbers might be different, but it's the same idea, okay? So the cal problem looks like this. So you have some sort of barn, right? Mine is 11 by 11, okay? This is in feet, okay? So all units are in feet. I'm not gonna put the units in, all right? So that's that. And then you have a cow that's on a leash, right? So that's a rope. Mine is 120 feet long, okay? 120. So there's a cow. Cow's here. Cow. Okay. So this cow is going around eating grass, okay? Now they even drew a picture for you, right? Correct? So they say it goes around to eat grass. So there's two parts. One is you have to consider the vertical part of this. So you'll get like this whole area, which is part of a 3/4 of a gigantic circle of 120 radius. And then there are two parts that are smaller, because you can't really turn that way. So you get like this part, and the other part you can kind of like get this part, right? They tell you to break it down, right? So you have an A1, which is the whole thing. And then you have A2, which is these two. And then you have an A3, which they tell you to get this part in, which is just this part. So we're not including the bar, okay? So these are the three parts you're looking at. So we're so good? So first, let's write out some dimensions that we need, okay? So first off, this whole thing is 120, so this is 120, so that means this part is 109. Do you agree? 109, 109, 109, 109. Okay? So yours might be different, but these are, I subtract 11 from 120 to get these segments. So these are all part of the big, this is a circle. This is part of a smaller circle. This is part of a smaller circle. But these two are symmetric, so these two are identical. Okay? So, first thing is I'm going to find this whole thing first. So I'm going to do A1. It's going to be, this is 3/4 of a circle, right? So it's pi r squared pi r squared, but it's times 3/4 because you only 3/4 of a circle. So that's going to give you what? Three 3929.20 feet square. Okay, so that's the first part. Keep this in mind, okay? This is this gigantic part. The next part is then this one, which is, you have to figure out what these two will constitute, right? But you kind of want to find the angle first, right? Because if you don't have these angles, there's no way you can find the area. So to do that, I'm going to rely on the following, okay? So I'm going to draw a extended line from the middle through here to here, okay? Why do I do that? Because now I have a triangle here. Okay, this triangle is important because with this triangle and with this angle, because this is a 90-degree one, so this part of the triangle is going to be 45 degrees. 45? Because this is half a square, right? Half a square. Square is 90, so half of that is 45. So I'm going to look at this triangle with 45 degrees to this length, 109, versus this angle to that. So right now you have two sides and one angle on the side, right? So to find that, you can use law of sine to find it. So I can find this angle first and I can find that angle, okay? So let's just call this angle like alpha or something, okay? So sine alpha over 11, this over that, okay? It's equal to sine 45 over 109, which then alpha will turn out to be, I'm looking for a small angle, okay? So inverse sine 11 sine 45 over 109, which is 4.09 degrees. Okay, that's alpha, which is this part. Then to find this angle right here, I would use 180 minus 45 minus 4.09, because this is a triangle, they add up to 180, right? So I'm going to use that, and I'll get got 130.91 degrees. Okay, this is important because this is going to be used for this part, but also this triangle. Okay, all right, so time to do A2. Okay, A2 includes two sectors, here and here. So because there are two of them, I'm going to use 2. Okay, so first of all, let me find this angle first. This angle is then 130.9, so 180 minus that, right? Because this is 130.91. This angle right here is 130.91. Okay, this one right here. So 180 minus that is 49.01. 49.09. Okay, that's that angle. All right, so I'm gonna use that. We get 1/2. Not one. Okay, so square, r is 109 here, times 49.09 over 360. What am I doing here? I'm doing this because this is the proportion that I'm using out of the full circle, which turns out to be 9.92 times 2, which turns out to be, okay, so I'm going to do the connection. And this is the two sectors. Okay. Now finally, I'm going to do the triangle here. Okay. So I'm going to do two triangles. 3 is equal to 2 triangles minus the square. Okay. So the sine, because this is the angle that is in between, right? 11 square. Okay, which is just 906.13 minus 121. Okay. So see. I think my bit rate is falling low a little bit, but you subtract this, and then you will get a 785.13 feet square. Okay, so finally you add these three together. Okay, once you add them all together, so it's A1 33,929.20 plus 101.79 plus 785. You add it all together, should end up having I mean, your numbers might be different because your dimension's different, but the method is the same. So there are 3 parts of this area. The first part is the big part here, which is 3/4 of a circle. And then there's these two smaller segments of this smaller circle. And then there's a triangle, two triangles, and you have to subtract out the bar. Okay? So first, we did the area 1 easily by doing 3/4. Area 2 and 3 sort of goes together because you kind of need to find this angle here. And to do that, we use law of sine because we know these two sides and we know this is 45 degrees. We use law of sine to find that angle, 4.09 degrees. And we can find that, which is 130.91. Once you get this one, you can use 1/2 AB sine to get this triangle and this triangle, and you take out the bar. Also, because you know this angle, you also know this angle, then you can use the sector proportion formula to get these two areas. Okay? Once you get that part, you're done, pretty much. Just add them all up. Just remember to subtract the 11 square, okay? Because that's the bar. All right. Any immediate questions? Please. Esther, you still around? Any clarification you want from me? Okay, great. I think I already did earlier this stream, so if you just click, I think I did it in the very beginning. So just click, this is the first problem on this stream. So just drag the stream back so you're no longer alive, then you can see the problem. Number 10, that's the maximum minimum problem, right? So just drag it back so that you're no longer live. You're looking at the recording. Does that work? Okay, so yeah, that was the first time I went over today. If you can't find it, let me know. But later on, in about like 20 minutes or so, this will also be uploaded automatically, so you can look at it as well. Okay. If nothing else, then I'll close the stream then. I'll see you guys in class. All right. See you. Bye.